Hello, good evening. Welcome to the new session of Premade Pro. Here we are studying about the human heart, the human circulatory system, and yesterday I have drawn the anatomical features and some of the basic functions of the heart. So today we will start from the depolarization and repolarization of the heart and will proceed to the cardiac cycle. So today let's start from the polarized or depolarization of the cardiac muscle. So what happens? This is the lecture number 6. Okay, so yesterday I have completed a basic given the outline knowledge about the polarization and depolarization and repolarization of the heart and the millivolt that are being required for the depolarization and repolarization of the heart of the cardiac muscle. Okay, so cardiac muscle mainly consists of the myocardium. Okay, so as per the previous lecture I have already said that our heart is myogenic in nature and it is auto-excitable. So what function are the exciting features of the heart? The sinoatrial node, which is called the natural pacemaker of the heart. Okay, well I will say that again later. Okay, let's start with the polarization and depolarization. Polarization and depolarization of cardiac muscle. So what happens? Let us draw. Let it be the cardiac muscle. This is the cardiac muscle, where the negative charge is inside the cardiac muscle and the positive charge is outside the cardiac muscle. Okay, now it is minus 70 millivolt. The current here is minus 70 millivolt and this state is called as the polarized state. Polarized state means it is a relaxable state. The relaxable state of the cardiac muscle is called the polarized state. Okay, polarized state. Now again, this is the cardiac muscle. Okay, now outside it is negative and inside it is positive. This is called the excitable state or the depolarized state. Depolarized state. So what happens? The depolarized or the exciting state, it is also called excited state. Okay, now we come to the polarization, depolarization and again repolarization. Okay, what happens? First it is polarized, then it is excited, that is depolarized, again it is repolarized. Okay, so now we come to the nodal tissue. Give the heading as nodal tissue. Give the heading nodal tissue. Nodal tissue. So what do you mean by the nodal tissue? Nodal tissue at the one is the sinoatrial node, SAN. It is called the sinoatrial node, SAN, sinoatrial node. 2 is the AVN. AVN means atrioventricular node. Atrioventricular node. So one is sinoatrial node and another is atrioventricular node, the AV node. Okay. The third is the AV bundle. The fourth is Purkinje fiber. Okay, so The first one is the SA node, second one is the AV node, third one is the sinoatrial, first one is sinoatrial node, second one is the AV node, third one is the AV bundle, and the fourth one is the Purkinje fiber. Okay, so let us go to the description first. The sinoatrial node, the sinoatrial node. So what is the sinoatrial node? Another name of sinoatrial node, the natural pacemaker of the heart. It only sets the pace. It regulates the pace beating. Number of beats per minute are being generated here. Okay, it is the natural pacemaker of the heart. Okay, now what is this location? Location of SN, location of sinoatrial node. Location of SN, top right corner of right atrium. Let this is be the heart. Okay, let me draw it once again. This be the heart. This is the heart. Okay, let this is be the heart. Now what happens? If this is be the heart, what happens? This is the sinoatrial node. It is the right auricle, left auricle, or the left atrium. This is the right ventricle and this is the left ventricle. Okay. Now the SN. So it is the pacemaker. It is the pacemaker. The SAN is the pacemaker. It is the pacemaker. So maintain, what is the function? Maintains the normal heart rate or the rhythm of the heart. Maintain the normal heart rate. Okay, and initiates it also initiates it. As the heart rate, see, our heart is called myogenic because the heart itself has the auto initiation organ, that is the sinoatrial node. It initiates the beat of the heart. Okay, it initiates the beat of the heart. Now it can generate up to it can generate around 70 to 75 times action potential per minute. It can generate 70 to 75 beats per minute. That is, on average, the normal heartbeat is 72 BPM. Okay. Now, what comes to the AV node? AV node, from the name you can understand, it is atrioventricular node. I mean, there is some link between the atrium and the ventricle. Be it the atrium and this is the ventricle, there is a connection between the atrioventricular node. So the SA node sends the bits signal to the AV node. AV node sends it further to the papillary muscle, Purkinje fiber. Later the process goes on. Okay, so the AV node basically stays here. AV node. What happens? AV node gives the signal via this line. Okay, this is the connection of the AV node and gives the signal via to this line. Okay, here the AV node gives the total signal here. Okay, the total ventricle is controlled by the AV node, the atrioventricular node. Okay, now what happens? The AV node AV node. What happens? It is located, the AV node is located on the lower left corner of the right atrium. Okay. AV node is located on the lower right corner of the right atrium. Okay. Now, what happens? It can also generate heartbeat. If the sinoatrial node fails to generate the beat as per the requirement of the heart, requirement of the body, requirement of the heart, the AV node also gives the support to the SAN. Okay. The AV node also has the capability to generate 60 to 65 beats per minute. It generates 60 to 65 beats per minute. Okay. Third, we come to the AV bundle. AV bundle. What does the AV bundle? It arises from the AV node. AV नोड से ही इसका ऑरिजिन है. ठीक है. इसके बाद क्या होता है? passes through atrioventricular septum, AV septum, to emerge at interventricular septum and it also divides into left and right bundle. Okay, so you got it. So now come to the Purkinje fiber. The last one is the Purkinje fiber. The last one is the Purkinje fibers. So Purkinje fiber located along ventricles wall. Action potential 20 to 25 beats per minute. 20 to 25 beats per minute. Okay, so have you got it? Now this AV bundle plus the left and right bundle. So AV bundle plus left and right bundle, this together forms bundle of His. Sometimes in the ECG, when people normally get an echocardiograph done, ECG, see, interpretation is sometimes written as the sinus rhythm. Sinus rhythm means the rhythm that is coming in the ECG graph is probably normal. According to the artificial intelligence, the software installed in the ECG machine, it has interpreted that the sinus rhythm is following the sinus pattern. Okay. Now, sometimes you can see in the interpretation, it is given as the right bundle branch block, incomplete right bundle branch block. So this is the left. There are two bundle branch. There is the left bundle branch and the right bundle branch. So if there is a right bundle branch, sometimes no treatment is required, because it generally comes from the asthma or the COPD. If you treat the COPD or asthma, this generally gets treated. But if there is a left bundle branch block, then the medical intervention must be there. Okay. Now, so I am now drawing a pattern how the beats get transferred. So the beats will start from the sinoatrial node, then it will be transferred in the AV node, then it will be transferred to the bundle of His, then to total heart. Okay, Purkinje fiber and all. Okay, so I can write it. Bits are generated as in sinoatrial node. Then it is sent to AV node. AV node send in this to bundle of his. Then it is sent to Purkinje fiber. Okay. Now what happens next? Both atria, SA node sends into both atria. Then the atria depolarized. Atria gets depolarized. That leads to the atrial contraction, that is the atrial systole. Okay. Some problem is there in the pen, please wait. Atria depolarized. Now this leads to atrial contraction, that is the atrial systole. What happens next? So from the atrial systole, both from the Purkinje fiber, both ventricle sends the beat to the both ventricle, and then from both ventricle, the ventricular depolarization. Leads to ventricular systole. Okay, so now note, take it as a note. What to be noted? Systole means contraction, that is the depolarization, and diastole means relaxation, that is repolarization. Okay, completed. Now we come to the cardiac cycle. Okay, give the topic as cardiac cycle, very important topic. Cardiac cycle. So the total cardiac cycle takes about 0.8 second. Duration 0.8 second. It is alternate contraction oblique systole and relaxation oblique diastole of heart. It is atria and ventricle. Okay. Now the right pump. Okay, the right pump. Okay, from the right pump, the deoxygenated blood goes to the superior vena cava and via inferior vena cava it moves to right atrium, then it moves to tricuspid valve, then where it goes right atrium to tricuspid valve, then right ventricle, then it goes to the pulmonary artery. There must the valve between the right ventricle and the pulmonary artery is the semilunar valve, ACL valve, pulmonary artery. Okay, this is a simple. No. So what happens here? The sinoatrial node. What does the sinoatrial node do? The sinoatrial node generates the atrial systole. It generates the atrial systole. Atrial systole generate हुआ. इसके बाद क्या? धड़कन दे दिया, बिट्स दे दिया SA और नोड ने. SA नोड किसको ट्रांसफर किया? अट्रिया को. उसके बाद जो क्या होता है? साइनोएट्रियल नोड से कहाँ जाता है? AV नोड. AV नोड से कहाँ जाता है? बंडल ऑफ हीस. उसके साथ Purkinje fiber, PF. Okay. Now what happens? This the atrial systole actually, when the atria contracts, the tricuspid valve opens due to the pressure of the contraction of the atria. The blood comes from the right atrium to the right ventricle. Now this atrial systole generally gives 70% of blood filling. Okay. Now the sound is generated here. You can let the lub, the closure sound of the tricuspid valve, lub. Okay. First sound, lub, dub, lub, dub, lub, dub. It can be heard through a stethoscope. Okay. Now this generates the ventricular systole. It generates the ventricular systole. The ventricular systole. So the Purkinje fiber, when the ventricular systole is generated by the Purkinje fiber, it's for 0.3 second only. And atrial systole, write it 0.1 second. Okay. Now write it closure of AV valve, that is bicuspid and tricuspid valve. Okay. So ventricular systole 0.3 second. Now the dub, the second heart sound, closure of which valve? Say, try to say. आप लोग नहीं जानने जा रहे हो. Closure of semilunar valve, ACL valve. So now it becomes the joint diastole, JD, the joint diastole. Okay, it is of 0.4 second. Okay, now what happens? The left pump, that is the left side of the heart. O2 blood, pulmonary vein. O2 blood कहाँ जाता है? Pulmonary vein are which vein? Those veins are carrying oxygenated blood from the lungs to the heart. It comes to the left atrium. Then it goes to bicuspid valve, that is also called the mitral valve. The bicuspid becomes the left atrium is 30% filling is given by the left atrium, systole of the left atrium. Okay. Now here 70% filling by joint diastole. Here left ventricle. comes to the semilunar valve, then comes to the aorta. By the aorta, the blood goes away. Okay. Now, blood goes away from the through the aorta to the whole body. Now, what it comes? Note. The cardiac cycle. When the cardiac cycle begins, it is said that all the four chambers are in relaxed condition. Okay. All the four chambers are in relaxed condition at the starting or the beginning of the cardiac cycle. Cardiac cycle begins, all four chambers relaxed. 0.4 second. It is also called as the joint diastole. Joint means both atria and the ventricle are in diastolic condition. Okay. Now, JD, that is joint diastole, is 70% filling of ventricle. Filling of the ventricle. Okay. AV valve open. Now, atrial systole, that is the 30% filling of ventricle. While the atria contracts, 30% of the blood gets filled out. Okay. In the later videos, I'll try to do some animations. Okay. I'm trying of it. I don't get enough time after seeing patients, but I'll try. I'll try with the leading coaching institute, but everything will be free. AV valve open. Now from the ventricular systole, it is filling of aorta and pulmonary artery. AV valve closed while semilunar valve open. Now comes to, so while the ventricle contracts, the AV valve are closed, because if the AV valve are not closed, then what happens? The blood in the contraction of the ventricle may flow in the backward direction. So to prevent that, the AV valve are closed. So what happens? The blood is pushed throughout the pulmonary veins and pulmonary arteries, basically the pulmonary arteries, and the pulmonary arteries have the semilunar valve in them. Okay. So if there is a question arises, which arteries contains valves? Generally arteries do not contain valves, veins contains valves. So if there is a question that which arteries may contain valves, you can answer the pulmonary arteries, because it consists of the semilunar valves. Okay. Now, as the ventricular systole begins, what happens? Ventricular press down, ventricles contracts. The ventricle B is the ventricle, it contracts. Okay, it contracts. Now the AV valves closed to prevent the backflow of blood, What happens next? Further increase in pressure forces the semilunar valve to open. Further, the pressure increases, the forces the semilunar valves to open. Now, next, as blood moves to aorta and pulmonary artery, ventricular pressure decreases. As blood moves to the aorta or the pulmonary artery, the ventricle gets relaxed, the pressure is decreased. So what happens? Semilunar valve closes to prevent the backflow of blood, further decline in pressure and continuous filling of atria simultaneously push open the AV valve. All these system just gets completed in 0.8 second. All gets completed in 0.8 second. Okay, 0.8 second. This is the cardiac cycle. Okay, so for today I am ending up to here. In the next lecture I will continue from the later topics. Okay, thank you. Please subscribe this channel and share it with your friends. Thank you. Good night.